Hello everyone, myself Rohit Pandita. Now we are going to dis- discuss about classifications of database management systems. It has two types: relational data model and object oriented data model. A relation data model uses tables with rows and columns. Examples are MySQL. Object oriented data model represent data as objects with attributes and methods. Example are MongoDB. Classification based on user numbers. It has two types: single user system and multi user system. Single user system supports only one user at a time. Examples are MSSS. Multi user system allows multiple users to access data simultaneously. Examples are Oracle. Classifications based on database distribution. Central location. Centralized DBMS. Data is stored in one centralized locations. Distributive DBMS. Data is stored across multiple locations. Homogeneous. Use the same DBMS software everywhere. Heterogeneous. Uses different DBMS software but can still communicate. Here are some user interface: single user system, multi user system, centralized system, distributive system. Now we are going to have a look on why is database design important. Data accuracy and integrity prevents error. Performance optimization ensures fast query execution. Scalability supports further data growth without major changes. Security ensures data is protected from unauthorized access. The database design process. Phases of database design. Phase 1 is requirement collection and analysis. Phase 2 is conceptual database design. Phase 3 is choice of DBMS. Phase 4 is data model mapping. Phase 5 is physical database design, and phase 6 is database system implementation and tuning. Requirement collection and analysis. Understand what data is needed. Conceptual database design. Create a high level model of data. Choice of DBMS. Decide which DBMS to use. Data model mapping. Convert the conceptual design into a structured formats like tables, relationship. Physical database design. Decide how the data will be stored physically. Database system implementation and tuning. It means implementing, test and optimize the database. Here are some flowchart of it. Phases of database design: requirement collection and analysis, conceptual database design, approaches to conceptual scheme design. Centralized scheme design approach. All requirements are merged into one schema. Complex and requires resolving conflicts. With integration approach, different groups have their own schema which are later combined, more practical and flexible. Strategies for schema design. Top down strategy, bottom up strategy, inside out strategy, mixed strategy. Now we are going to discuss what is top down strategy. Start with a general high level schema and refine it over time. Example: start with company, break it down into employees and departments. Bottom down approach. Start with individual data elements and build a schema by combining them. Examples: define customer, order and product, then link them. Inside out strategy. Start with central set of concept and then separate outwards by considering new concepts in the vicinity of existing one. Mixed strategy. Use a combination of top down and bottom up strategies. Phases of database design. Many factors to consider for choice of DBMS: technical factor, economical factor, organizational factor. Factor to technical factor: types of DBMS: relational, non-SQL, NoSQL, object-oriented. Performance factors: economic factor, cost of software maintenance and training. Organization factor, preferences for specific DBMS, availability of vendor support, familiar of staff with the DBMS. Data model mapping. Mapping conceptual schema, convert entities and relationships to database tables. System independent design, logical design should be adopted to different DBMS. Physical database design. During this phase, we design the specifications for the stored database in terms of physical storage, structure, record placement, and indexes. Database system implementation and tuning. During this phase, the database and application program are implemented, tested, and eventually developed for services. Various transactions and applications are treated individually and then in conjunction with each other. The database and applications are built and developed. Check if the database performs are accepted. Tuning. Optimize performance